Welcome, ladies and gentlemen. What I'm going to talk to you about today is economics beyond equilibrium. Now, all of you who have been through economics classes will remember your very first economic class, and you will remember a graph somewhat like this. There will be a price on one side, quantity on the other. There will be a line going upwards, the supply schedule, and there will be a curve going downwards, the demand curve. And they will be meeting somewhere, which you will be told is the equilibrium price and quantity. So almost all of economics that you will learn from here on will effectively be various permutations and combinations of this basic idea. And as a result of that, you will end up thinking about the world in terms of what is called a general equilibrium, i.e. a gigantic machine that, if in a perfect optimal world, would end up at this general equilibrium. And you would be told about policymakers and consumers and other economic agents as being rigidly rational. You'll be told about marginal diminishing utility, and you'll be told about natural rates of interest and unemployment. Now, it may come as some surprise to you that this entire way of thinking is really the result of the fact that we are all thinking in a philosophical framework derived directly from Newtonian mechanics. So it is not so surprising that we use these terms like, for example, equilibrium or levers of monetary and fiscal policy or liquidity. Notice all of these are mechanical or hydraulic terms that are used in Newtonian mechanics. And so therefore we have constructed this worldview of this gigantic machine. The problem is nobody has actually seen an equilibrium. It is effectively a religious belief, if anything. Can you think of the word in terms of ceteris paribus, i.e. thinking of it, i.e. everything else being equal? You can't. In fact, we all live in a world where you do something here affects all kinds of things in other parts of the system. Can you really think in terms of natural rates of interest and unemployment? In fact, if you investigate any of these ideas, you will discover anybody calculating a natural rate of interest or unemployment is effectively basically talking about some sort of a moving average, nothing more. And there's nothing at all natural about this idea at all. So is there another way of thinking about this whole thing? Well, another way of thinking about this whole thing is to think of the world as a gigantic, complex, adaptive system. So, is it the case that this is the first time people are suddenly beginning to think about this world in this way? No, it turns out that we have been thinking about this alternative view of the economy for a very long time. In fact, going back all the way to Alfred Marshall, who made the point that an economy is not like a mechanical system at all, but much more like a biological system. A similar idea comes through from Friedrich Hayek in his Nobel Prize lecture, which he very provocatively called the Pretense of Knowledge. He basically mocked most of economics and said, you've got these mechanical models which always fail to predict what is going to happen, and yet you stick with them and you pretend to actually know what's going on. So he had this great quote, which I'm going to read from that lecture of his. He says, if man is not to do more harm than good in his efforts to improve the social order, he will have to learn from this. As in all fields where essential complexity is of an organized kind prevails, he cannot acquire the full knowledge which would make such mastery of events possible. He will therefore have to use what knowledge he can achieve, not to shape the results as a craftsman shapes his handiwork, but rather to cultivate a growth by providing the appropriate environment in the manner in which the gardener does this for his plants. The point is, the world or the economy is a much more organic thing. Yes, you can manage it, but in sort of the way a gardener manages his garden. So what is this complex adaptive system I'm talking about? Well, I'm basically referring to a system and it doesn't have to be only an economy, but there is a whole class of systems which exist, which are basically made up of large numbers of heterogeneous agents which are interacting with each other in all kinds of different ways and very nonlinear ways which are very often unpredictable. But yet out of this chaos is not entirely random. Instead, out of this chaos there is a certain type of organization, a sort of pattern that emerges. And there are many such systems existing in the world. So let me give you some examples of such systems. Cities, for example, are an example of a complex adaptive system. There are weather systems, financial markets, languages such as the English language, economic systems, of course, ecological systems, political systems. And notice that's not just economists who have discovered that, you know, complex adaptive systems describe the way the world is. Other fields of study have, over the last century or so, also flipped over to thinking about the world as a much more chaotic, complex adaptive system. For example, even now you will hear in terms of the idea of ecological balance, as if the ecological systems are in some sort of an equilibrium. But in fact, if you really think about an ecological system, the better way to think about it is in terms of a Darwinian arms race. This is a continuously, it's a complex world, but also continuously adapting world. So how do you define such a complex adaptive system? Well, it turns out there are some specific characteristics of these kinds of systems. First of all, they are made up of these bottom-up interactions between all kinds of agents, and there is, as a result of these interactions, a sort of organization that emerges. But it's not because of some top-down organization. It happens because of the complex interactions between these. So I just described, for example, the English language or a city. There are all kinds of patterns that exist. It's not just because the mayor from top there is telling you how it should evolve, or for example, the English language. The way the English language is actually used is not because the grammar book Wren and Martin described it in a particular way, and far from it, it's continuously evolving. Similarly, these systems are non-deterministic, but they are path dependent. Now, what do I mean by that? They're non-deterministic in the sense that ex ante, it's impossible to tell where this thing is going. Very different from a Newtonian system where you have a clear path. If you did A, B, and C, then you are likely to get an outcome D. In complex systems, you, on the other hand, there are many different paths down which you can go down. Now, some paths that this can go are more probable than others, but, and this is why it's interesting, they are path dependent. Once you go down a certain path, no matter how improbable it was to start with, that is now hardwired into this system. So let's take, for example, in political systems, ex ante you may have thought of, say, the election of President Trump as being improbable. You may have thought of the assassination of Kennedy or the assassination of Indira Gandhi as being very improbable events, ex ante. But once they have happened, they are now a part of how that political system is going to proceed. It doesn't matter ex ante how improbable it was. Now, notice how this different is from a Newtonian system. Tossing a coin, no matter if they were evenly based coin, it will have always the next time you toss it, it is always a 50% chance either way. No matter how many times it has been tails before it, no matter how many times it has been heads before that, the next toss is always a 50-50 chance. So this is a very different. If tossing a coin was a path-dependent activity, then this would not be a random event going forward. It would have influenced the way it behaves. And this is true of countries. It behaves on economies because you accumulate institutions, you accumulate culture that then get embedded into the way people behave. Then there is the issue of feedback loops. Now, in Newtonian economics, there are no feedback loops. That is why you are able to talk about ceteris paribus, because you are able to isolate a certain activity. Now, of course, crudely feedback loops are put into even into Newtonian systems, but they happen in as I said, deterministic kind of way. But in a non-deterministic way, you'll get all kinds of feedback loops coming back at you at multiple sorts of ways. And this fits together with another characteristic, which is that these systems are not sums of their parts, i.e., in complex systems, simply adding up the bits doesn't tell you anything about how the whole works. So no matter how much research you do into a single ant, it will not tell you anything about how an ant colony works. No matter how much research you do into the etymology of a certain word in the English language, it will tell you nothing about how it is used in real life. No matter how much research and how well you describe every building in a particular city, it will tell you very little about how that city behaves in real life. So this is why it's not the sum of its parts. Then of course there is the capacity to adapt. It is evolving. It's not as if just because something was true 10 years ago, the same set of circumstances will lead you down the same path. And remember, that's part of the point I made earlier about non-determinism. And of course, due to all of this, you have these systems are highly nonlinear, and you have butterfly effects. What do I mean by butterfly effects? Well, a very small hit may have a very large impact. Conversely, a very large shock may have a very small impact. So what this does is suddenly creates an environment which is very different from the environment that Newtonian mechanical economics tends to describe. But you will have noticed that it describes the world you live in real life, much, much better. So rather than think about those old rigid models, let's delve into the world of how to deal with this rather complicated, unstable universe. So here are some examples of complex adaptive systems. I've given very simple ones. The first one is called the murmuration of birds. You may have seen it otherwise as well. This is the example of the Mahakal temple in Ujjain. And you have these birds doing what is called murmuration, flying around almost like they are doing a parikrama around the temple. Now, notice that this group does not have any leader. They are clearly behaving and interacting with each other in multiple ways, but while there may be a certain chaotic behavior in the sense that almost nobody can predict exactly what they will do in the next instance, this is not random behavior. There is a certain pattern to the behavior. So where is this coming from? How are they going about this? So this is the issues that people who think about complex adaptive systems think about. Another example, peak rush hour pedestrian traffic in a location, I think it's in Delhi if I'm not mistaken, in Nehru Place. They are walking around. Again, notice that the way the human beings are walking around there is a certain pattern to the way they're going. It's not entirely random. So it is very important then to understand what is it that allows this kind of self-organization. Well, the thing that allows the self-organization in complex systems is something called attractors. Or this is true of chaotic systems in general, not just complex systems. And there are some specific kinds of attractors called strange attractors. But let's just, for the purpose here, talk about attractors themselves. Attractors are the organizing principle around which these complex systems self-organize. So the formal definition would go something like this. Complex systems tend to evolve into a state of an attractor or the system's guiding principles with the emergence of patterns of self-organization within which interaction between agents further evolution of the system occurs. So these could be many things. For example, in the case of the murmuration, the thing that allows this behavior is actually the birds. Individual birds just simply follow a simple rule about the distance that they maintain with other birds. This is what scientific research suggests. Now, each bird doesn't know what the overall pattern is. They're just following simple rules at an individual level. Those simple rules or rules of thumb allow this overall pattern to evolve. Same thing is happening, for example, with human beings. You are seeing patterns through the day in traffic or human movement in a city. Now, this is defined. What is the attractor here? Well, simply office timings, peak hour. It could be the way the traffic networks have been laid out. and it could be way, for example, in that particular case, the street hawkers have laid out their ware. So these then become the guiding principles of the behavior of these agents, and therefore these are the attractors of that system. Now, how do human beings deal with these complex systems that we now witness? So if people are living in this extremely non-deterministic, chaotic, adaptive environment, how do they deal with it? Well, we deal with it by doing something called satisficing, a term that was introduced by a very well-known economist, Herbert Simon, in the 1950s. He argued that unlike what standard theory says, which is that human beings try to optimize rationally, what most human beings are doing is basically trying to satisfy, basically making do somehow. And how do we make do somehow? We basically use rules of thumb, or what economists like to call heuristics. We like complicated terms, but basically they are rules of thumb. And we use these rules of thumb essentially to make sure we somehow make our thing through the world. We only will apply our mind and try to improve it when we really have to optimize for some limited purpose. For most of our time, because of the uncertainty of what we are dealing with, we just use rules of thumb. The question then is, how do we arrive at these rules of thumb? Well, one way in which we arrive at rules of thumb is simply by responding to the context in which we are. Now, this is a very powerful influence in the way we behave. This is the reason, for example, the same person who will drive in an extremely aggressive way, break all the rules on the streets of Delhi, the same person will go to, say, Europe or the US and will drive and follow every single rule there is. Why? Because the context has changed. And there is a very famous experiment. In fact, there are several experiments to show this. There's, of course, one is well known, it's called the broken window experiment. But here I'm going to talk about another famous experiment called the Stanford Experiment. It was conducted in 1973 in the psychology department at Stanford, and it found something quite interesting. So the experiment was done in the following way. A class of students was divided into two. One were the jailers and one were the prisoners. Now there's a completely arbitrary division between two groups of people. And then they were asked to role play in a closed environment. So one of the group could do whatever they thought a jailer should be doing, and the other group was basically be treated as prisoners. Now remember, they are just classmates. There's no particular difference between them. They are randomly divided into two groups. And yet, after a period of time, it was discovered that those who had been designated jailers began to boss around the prisoners, and this behavior began to accumulate to a point that these jailers began to actually do fairly, one could even say, cruel things to their classmates. And this went on to such an extent that at some point the experiment actually had to be stopped because the experimenters were scared that somebody would get badly hurt. So here are some photographs from the original experiment. The idea here is to simply show how human beings behave. Here is the first photograph. You can see they are being made to do push-ups or whatever it is, some sort of a punishment that they are being, the guards are forcing the prisoners to do. Here are other things that the prisoners were made to do by the guards. There is a video which will also show, if you play it for a few seconds, you will see that again the prisoners actually rioted or at least stopped listening to the guards as a result of this behavior, and elicited a fairly strong response back from the guards.
Because the first day passed without incident, we were surprised and totally unprepared for the rebellion which broke out on the morning of the second day. When waking the prisoners for the 10 o'clock count, The morning guard shift found that the prisoners in cell number 1 had removed their stocking caps, ripped off their numbers, and barricaded themselves inside the cells by putting their beds against the door. The prisoners began to taunt and curse the guards to their face. This, of course, embarrassed and upset the guards. The morning shift immediately called in reinforcements. They asked the night shift to stay on, and they called up 3 other standby guards to help put down the rebellion.
Now you can see from the video what happened, but this sort of behavioral context changing response happens in many other ways. We just gave you one example here, but this is behind much of what modern behavioral economics tends to argue about. You may have heard of the idea of Richard Thaller's nudge. He's written, of course, a very famous book about this, but this general context has now been found to be an extremely useful economic tool. I'm going to just give you a couple of examples here. There is, of course, there is a natural experiment that was came together as a result of organ donation in Germany and Austria. Now, in Germany, what happened is that its rules said that those who wanted to opt for organ donation had to opt into this scheme. Whereas in Austria, it was the exact opposite. There, they allowed those who wanted to opt out of the organ donation, but if you didn't actively go out and opt out, you would continue to be an organ donator. Once you died, your organs would be used for medical purposes. Now notice that Austria and Germany are about as close culturally as you can get. They're right next to each other, they share a language, they share culture, everything. And yet, it was found that Germany, less than 15% of the people opted in, whereas in Austria, 90% of the population opted in. Why was this big difference there? Simply because the default option in Austria was to opt in. So most people essentially went with the flow. So another example of how simply the context meant that 90% of the population was willing to opt into a scheme, whereas in Germany, exactly the same in every other way, because they had to actively opt in, they didn't do, only 15% or less opted in. So the point here being made here is that for economic policy making, we need to understand that the default setting matters. We have a similar example which is also mentioned in this presentation, which is about a large US corporation wanted to increase automatic enrollment in its pension and savings schemes, and it found that again the default option had a huge impact on the behavior, even though the choices themselves had not changed. Now, standard economic theory simply cannot explain this, because that would expect that you would have rational people evaluating the choices and behaving in a certain way, whereas in fact the major thing driving human behavior was simply what the default option was. Now, there are many other ways in which nudge and context is used. Some of these are being used in India as well. The Swachh Bharat mission is a good example of this context or nudge behavior leading to behavior change. Now, as recently as 2014, barely 36% of Indians had access to a toilet. Now, that's quite shameful in some ways that so many years after independence that barely a little bit more than a third of Indians had direct access to a toilet. Now, the thinking was that people didn't build toilets because the general context was that it was okay to do open defecation, and this had many quite apart from the purely aesthetic problem, there was obviously also problems with disease, sanitation, and many other spin-offs that were a problem of this behavior. Now, a major project was put in to build toilets across the country, and when of course people began to build these toilets, many critics said, look, you got to build all these toilets, nobody will use it. After all, Even those in the villages, for example, who can afford a toilet don't bother to build one. It's not necessarily access to toilets. Others said that the toilets will be built, but they'll be used to store hay or grain or whatever it is, everything other than actually being used as a toilet. Many other criticisms were made. But as these toilets were built out, by 2019, more than 99% of the households across India actually had a toilet. And it is true that in some places they were used for things which are nothing to do with being used as a toilet. But something else happened. Essentially, enough of those toilets began to be used that the context changed. In other words, in an area where open defecation was the natural course of behavior, now more than half began to use the toilets. Now once that happened, very quickly the whole system switched over, and only a very few holdouts would continue with the old pattern of behavior. Why does this happen? Why did it happen? Is it because everybody suddenly decided that one was better than the other? No, it simply happened because the context changed, i.e. the cultural environment simply switched over, and therefore since that was the accepted behavior, everybody began doing it. And of course, we have subsequently seen recently that many of the benefits of improved sanitation in terms of health outcomes have also followed through. But the same thing is true of cleaning up cities. One of the things that will strike any of you who have traveled outside of India is how much dirtier Indian cities are. And it's not just about poverty. Go to, for example, Vietnam. Vietnam is a country with per capita income which is roughly the level of India, but its cities are clearly cleaner. So what does one need to do in order to begin to clean up Indian cities? Because clearly that has not just health outcomes, quality of life is clearly directly related to having cleaner cities. So we found that there are two experiments that are being done, and maybe they will spread. One of the experiments was that Indore city, a few years ago, maybe about 3 years ago, decided that it would carry out one major cleanup, and then for a period of time would simply enforce garbage clearance and other such things. Now what has happened, interestingly, 3 years have passed since when this was introduced, and the city, of course, it went through a major cleanup. But what is interesting is that now the behavior has changed such that even with relatively low amounts of effort, the culture of Indore is such that this thing can be sustained. A little bit of reinforcement is still needed, but basically Indore is now clearly the cleanest city in India. What is equally interesting is other cities in Madhya Pradesh like Bhopal and other, Ujjain and so on, have seen this experiment and have asked for this experiment to be replicated. And so, oddly enough, a city like Indore, which I remember from 15 years ago, used to be a dirty industrial city, is not only the cleanest one, but the rest of the cities in the same state have also dramatically become cleaner as a result of this example. As I said, context mattered. Another example that has happened, say the area around the Golden Temple complex in Amritsar, again it was redesigned, cleaned up, and significantly cleaned up, as a result of which even those parts of Amritsar that were not part of this project have slowly begun to become cleaner. So clearly context matters. There's another one that is ongoing, the idea of the Insolvency and Bankruptcy Code. The idea here was to improve debtor behavior, change in business culture, and again, as spoken about in the economic survey recently, this has led to significant changes in business culture in India, and hopefully that too will be sticky. So far I have talked about one of the ways in which rules of thumb are arrived at, which is from the idea of context and behavioral change. Another way in which this happens is through feedback loops or learning by doing and so on. So I am going to show you here a very commonplace video of a dog catching a frisbee.
A long pass. Go get it. Go get it. Go get it.
Now, how does that happen? I'm sure many of you have seen a scene like this in a park near your home. essentially the owner indicates roughly the direction in which he will throw the frisbee. The dog side of goes into position, the frisbee is thrown, the dog runs along and catches the frisbee. Simple thing. Now, unfortunately, this is not how Newtonian economists would go about it. The Newtonian economists would do the following thing. They would first go into the park and measure the speed of the wind. Then they would do a lot of research into the breed of the dog. And then they would look at the angle at which they will throw the frisbee. They will look at the design of the frisbee and their muscle strength. They will do all kinds of probabilistic analysis of the power with which they will throw the frisbee, and they'll feed it all into, as you may be all aware of, something called the computable general equilibrium model on an Excel sheet. And after many iterations of meddling around with that Excel sheet, they will get a forecast, and if they happen to be policymakers like myself, they will probably take this forecast to a frisbee policy committee, and the frisbee policy committee will then give forward guidance. Now, on the basis of this forward guidance, the economist will take his dog to the park. He will plant his dog in the place where the forecast said the frisbee will land. He'll go back to his original point and throw the frisbee. And the frisbee will fly through the air and almost certainly land somewhere else, and the dog will fail to catch the frisbee. Now, nobody other than the economist is going to be surprised by this outcome. So, the point I'm making is, even something as simple as throwing a frisbee in a park is a complex system problem. The wind may be slightly different, the design maybe of the frisbee may have a small scratch on it, and you may throw the frisbee at an angle or a strength that is different. There are many multiple factors which will cause the frisbee to go somewhere other than where you had thought it should go. And we should expect this to happen. So the question is, how do the non-economist dogs catch the frisbee? The way the non-economist dog goes about it, first of all, he or she doesn't bother with forecasting. Instead, what they do is to watch the frisbee very clearly. As you saw in the video, they run along with the frisbee, watch the frisbee. Run along with the frisbee, watch the frisbee, and then at the last minute, jump, catch the frisbee. What are they doing? What the dog is doing, feedback loop and adjust. So this feedback loop and adjust is something we all do all the time. Anybody who plays sports is adjusting their body along to try and hit the ball, and we are doing that multiple ways through the course of our lives. We do something over and over again, and with that we derive certain rules of thumb that this is what will lead to good outcomes. Now, there are formalized way of doing this as well. For example, you have something called agile systems. This is where this is a well-known way in which software, for example, is introduced and it's kept flexible so that there is, after you put it in, you have continual learning and improvement of a system that has already been introduced. Artificial intelligence very often is based on essentially learning from large number of iterations. Beta testing is done like this, but you know, there are many, in economics, there are many times in which we have to do this, particularly when we are dealing with very complicated reforms. This is how we do it. Very recently, we carried out the introduction of two very major reforms in India, the GST, or the Goods and Services Tax, and the Insolvency and Bankruptcy Code. Path-breaking changes which we had debated for decades on end. And everybody said, you know, we must make it the best possible thing, introduce it so that, you know, it happens as smoothly as possible. The problem is that these are complex systems. Nobody really knows what the introduction of something like GST into a complex country like India was going to do. The only way to find out was to actually do it. The same thing was true of the Insolvency and Bankruptcy Code. When you began to introduce an insolvency bankruptcy code, a bankruptcy system in India, nobody actually knows ex ante what the outcome of that is going to be. The only known way of doing that is to do it. The problem is, of course, that no matter how much you plan, many of the unintended consequences, butterfly effects and other things that appear as a result of this are those that you could actually have predicted to start with. So how do you go about it? essentially by doing the same thing is feedback loop and adjust. So if you will see, we have through the course of the last couple of years that we introduced these, they were very disruptive changes, but we have continuously had to adjust them. This is not due to bad planning, as many people may try to say. There was no other way to have done it. To have attempted to have this perfect plan meant, which we tried for 20 years, that we would never have done it. So to do some major changes, you have to introduce it, keep it flexible, and always be willing to change along the way. Now I'm going to illustrate this general idea of dealing with complex systems as something to do with flexibility and active management as opposed to rigid master plans. And I'm going to do this with an example from another kind of complex adaptive systems, cities. Now, the usual story which people have in their mind, particularly in India, is that what you need is rigidly master planned cities. And the idea is, if you have a really good plan and implement it as perfectly as possible, you would get this great perfect city. So therefore, everybody thinks that Chandigarh is a great masterpiece of master planning, or that Dwarka, which was based on similar ideas, would consequently lead to great urban outcomes. And the idea then is in people's heads, if we do a really good job, then they will end up somewhat like great cities of the world like Singapore or London and so on. So what does the morphology of a city like Chandigarh look like? So this, as you can see, very famously, the grid pattern of Chandigarh, it's got all these very well planned. And the idea would be, hey, because it's so well planned, if we implement it and stick to it, we would end up with this great city called Chandigarh in a few years' time. Now Chandigarh, remember, is already half a century old. So by now we should have begun to have those outcomes. The same thing you can see Dwarka in Delhi. There's a neighborhood, very rigidly planned, straight roads and everything. But is it the case that if you made Chandigarh work very hard and you did a really good job of it, would it end up as Singapore, which most people will agree is the best managed city and most efficient city in the world? This is what Singapore looks like. No grid, it's all over the shop, doesn't seem to fit any of those patterns which you saw in Chandigarh or Dwarka. And yet this is indeed the cutting edge of urban landscapes. Messy as it may look, why does it feel so much more ordered on the ground when all those plans of Dwarka and Chandigarh do not apply here? In fact, as many of you who live in Delhi will go to Dwarka, you will see on the ground it is completely feels like it is not in control. Even those who live in Chandigarh, despite the fact that it's a very tiny population for the size, you will find that it is nowhere near as successful an urban outcome as this messiness of Singapore. The reason for this is the same point I made earlier. In a complex adaptive world, you need to continuously adjust for context, adjust for the fact that you are going to get unintended and unpredictable outcomes. So the success of Singapore is not the success of great long-term planning. The success of Singapore is really that of continuous adaptation. And if you want another example of this, in fact, it is London. If you see London, Singapore is only the adaptation of a relatively short period for the last 200 years. London is a much older city going back to the Roman times, and it is consequently even messier an outcome of layer upon layer of urban building and rebuilding. And you can see it is even more unlike Chandigarh. I'm sure everybody will agree that London and Singapore are better outcomes than Chandigarh and Dwarka. So what is the conclusions we can reach from all of this? And I'm going to end with one slide where I will give which includes a quote by one of my favorite military tacticians, in fact Helmut von Moltke the Elder. He was a Prussian general in the 19th century, considered one of the greatest generals of all time. And he said basically that no plan of operation extends with any certainty beyond the first contact with the enemy. The point he was making is that once you collide with your enemy in a military outcome, no matter how much planning you have done, the actual play of the battle is going to go in all kinds of unintended and unpredictable ways. And so this is also true of economics and virtually every other kind of complex system, whether it is the evolution of the English language or it is the evolution of a financial system. Now, what are therefore the recommendations and conclusions? First, let us recognize that we live in a complex adaptive world and not in a Newtonian world. This is a first and most important thing to learn. Second, the fact that faced with this complexity, human beings navigate this unstable world using heuristics to suffice. This is a point that Herbert Simon had made some time ago. And heuristics is derived by various strategies. I've just given a few through context, through feedback loops and so on. And the last point to be made is that flexibility and active management will always win over rigid prescriptive plans. The same reason why the Soviet Union with its heavy planning, or in fact Nehruvian India with its 5-year plans ultimately failed, is got to do with the fact that there were rigid prescriptive plans, and flexible systems will always win the longer run. So what should you do, say a policymaker like me who is involved in things like regulation? Well, it says that clear, simple regulation combined with supervision will always win over heavy prescriptive regulation. This is a very important point. Those of you who wish to ever go into policy making and regulatory activities should always remember this. Thank you very much. I'm just going to give you a list of readings that you may find interesting on this topic.